Hi there. In this video, I want to talk about the concept of symmetry and functions. So when we talk about a line of symmetry, this is a line that cuts a figure in half. Okay, so it cuts a figure in half. All right, you can also think of it as like reflection symmetry, okay, where if you put a line of symmetry on a figure, then it will reflect that figure across that line of symmetry. So let's look at a couple of examples. Okay, so as I look at these four graphs here, what I want to identify is where do we have a line of symmetry? And so let's look at this first graph. And what I notice is that if I were to draw a line down the center of that graph, then this graph is symmetric across the y-axis. Okay, all points, it's like a mirrored image. Like if I take this and I mirror it over, it'll go on top of this piece. All right, same thing with our second one. Now this one is reflected across the x-axis. All right, and so it's mirrored. This part of it is cut in half and mirrored across the x-axis. Now this is another one where we're reflected across the y-axis, so our line of symmetry goes across our y-axis. And then over here, there is no line of symmetry. All right, there's nothing in here that I could cut in half on this. All right, so let's look at a function that is reflected across the y-axis. All right, so one of the important things that we need to talk about with functions is when a function is symmetric about the y-axis. So if we think of the function f of x equals x squared, okay? This function is a parabola, all right? And this parabola looks like so. And we've got some important points on that graph. And so I know I have the point 1, 1. I've got the point 2, 4. And we've got the point 3, 9. All right, same thing over here. And all these points are reflected across the y-axis. So this is the point -1, 1. This is the point -2, 4. And this is the point -3, 9. All right, so when we look at this, all right, each of these values are just reflected across the line x equals 0 or the y-axis. Okay, that's our line of reflection. Each of them are equidistant from our line of symmetry or line of reflection, however you want to call it, but we'll call it symmetry, or line of symmetry. So knowing this, okay, what's important about this function is that this is what we call an even function, okay? So an even function is defined as such, okay? And what that means is that if I take f of negative x, then we're still going to just get f of x, okay? So this is a little tricky. This is a little hard to understand, but here's what I mean by that. All right, if I take a function and if I plug in, say, 1 in, let's do 2 into this function. I like that one better. If I wanted to calculate f of 2, all right, what I'm going to do is I'm going to plug 2 into x of my function up here. All right, so this is really going to say 2 squared, which means that we're doing 2 times 2, which gives us a y value of 4. And you can note that in this point here. All right, the x value is 2, the y value is 4. All right, so f of 2 is equal to 4. All right, now if we do the opposite, all right, and we plug in, say, f of negative 2, we plug in that negative value, then what happens is we're going to do the same thing. We're going to plug in negative 2 in for x here and see what we get. So if I plug in negative 2 into this function, I have negative 2 squared, which means I'm taking negative 2 times itself, so times negative 2, and that's going to give us a value of 4, okay, as well. Negative 2 times negative 2 gives us 4, all right? So it's important that we see that, all right, because what I've got is I've got f of 2 is equal to 4 and f of negative 2 is also equal to 4. And when I do that, I'm going to rewrite these down here real quick. Okay, and so when I plug in 2 into our function, we get 4. If I plugged in the opposite value of negative 2, we get the same y value of 4. All right, so it's an even function. That's what that means, that if you plug in an x value and you plug in its opposite value, then you get the same output or the same y value. Okay, so what I want to show is that these x values are opposites. So x value is opposite, and the y value that we get is the same. Okay, that's what an even function is. Now we could use function notation and use that x value to show that as well. Like, we know that our function f of x is equal to x squared. Now if I plug in negative x into this function, if I calculate f of negative x, then that's going to give me negative x quantity squared. Now negative x squared means that we've got negative x times negative x. A negative times a negative gives us a positive, so this is really x times x, which gives us x squared. So even if we plug in a negative input, all right, the opposite value, f of negative x is still going to equal x squared. And that's what this definition means, okay? The next thing I want to talk about is this concept called symmetry about the origin. This is also often referred to as rotational symmetry, okay? And so let's look at a function that has that's symmetric about the origin. So this is an example of a function that is symmetric about the origin. I can't draw in any lines of symmetry on this function, but what we can do is we can actually rotate this thing around 180 degrees and get the same thing, all right? And we call that rotational symmetry, okay? However, this is also called an odd function, okay? And that's what an odd function means, that it's symmetric to the origin. And here's what I mean by that, all right? This is the function f of x is equal to x cubed, all right? It's called a cubic function. Now, we've got some specific points on this graph that I'm going to label as the point 1, 1, and then the point 2, 8. All right, this has the point down here, -1, -1, and then this point down here is the point -2, -8. All right, so from here, what I want to show you is what an odd function means. All right, so an odd function really means that if you take f of negative x, then that gives you negative f of x, all right? By definition, this is what an odd function means. Kind of hard to see that, all right? But what I want to do is let's calculate, say, f of 2, all right? Let's do 2 again, all right? So if I plug in 2 into this function up here, it's going to give me 2 to the third power, which means that I'm going to take 2 times 2 times 2. 2 times 2 is 4, times another 2 gives me a value of 8. So what we know is that when I plug in 2 for my x value, I get 8 as a y value, all right? So that function exists. Now, the thing about an odd function is that let's plug in our opposite value, all right? Let's plug in f of negative 2, and let's see what happens. So f of negative 2, still going to just plug that into our function, x cubed. So we're going to take negative 2 and we're going to cube that. And that's going to be negative 2 times negative 2 times negative 2. Now, negative 2 times negative 2 gives us positive 4. Positive 4 times another negative 2 gives us a negative 8. So f of negative 2 gives us a negative 8. All right, and when we do this, we get an odd function. And what that means is that if we take our x value, plug it in, get a y value. If we plug in the opposite x value, the y value should also be opposite, and that's what that means, okay? So, let's write that out real quick again. And so if I write out these function values, f of 2 is equal to 8 and f of negative 2 is equal to 8, if we have an odd function, then what we have to see is that if we plug in opposite x values, so the x value is opposite, all right, then what I'm looking for is, are my y values opposite? So y values are opposite, and that is an indication that we have an odd function and that our function is symmetric to the origin and has rotational symmetry. All right, now by definition, what I can do is, given this function here, f of x equals x cubed, all right, if I plug in negative x into that, all right, then what happens is I'm going to have negative x quantity cubed, which means I'm going to take negative x times negative x times negative x. Now, negative x times negative x gives us a positive x squared, okay? And then multiply that by another negative x. A positive times a negative is going to give us a negative, so we have negative x cubed, okay? And so what we have here is we have f of negative x is equal to negative x cubed. And what we've done is we've taken that entire function, which is x cubed, all right, and we've made that negative. And that's what's happening in our definition, okay? So you can always check this by definition if you want. However, I think it's much easier to just use numbers because it's a lot easier to see that, okay? Let's look at a couple of examples. All right, so on our last example, what we have to determine is our function even, is it odd, or is it neither? Okay, so it's got to be one of the three. All right, so what I want to do is let's plug in f of 2. All right, let's just figure out what f of 2 is. So when I plug that number into our function, that's going to give us 2 cubed minus 2 squared. Okay, and so using order of operations, what we want to do is do our exponents first. So f of 2 is equal to 2 cubed, which is 2 times 2 times 2, which is 8, minus 2 times 2, which is 4. So 8 minus 4, and we get that f of 2 is equal to positive 4. Okay, and that's our value. All right. The next thing we want to do is if we're determining this, is to now plug in f of negative 2 and see what we get. Now, if we get the same y value of 4, then it's even. If we get an opposite value, it's odd. And if we get something not 4 or negative 4, then it's neither. Okay, so let's do that. All right, so let's plug in the quantity negative 2 cubed and then minus negative 2 squared. All right, so from here, when I'm doing this, negative 2 cubed is going to give us, and let's write this out because the negative ones are kind of tricky. We've got negative 2 times negative 2 times negative 2 minus negative 2 times negative 2. All right, so multiply first. So negative 2 times negative 2 is positive 4 times another negative 2 ends up giving us negative 8. All right, so let's write this out as negative 8, and then minus negative 2 times negative 2 gives us a positive 4. So you have negative 8 minus a positive 4, which gives us a value of negative 12. So f of negative 2 is equal to negative 12. And so because these numbers of 4 and negative 12 are different, all right, then we have neither, okay? If we got that f of 2 is equal to 4 and f of negative 2 is 4, then it's an even function. If we got f of 2 equals 4 and f of negative 2 equals negative 4, then it would be an odd function. But because these are completely different from each other, then these are neither odd nor even. All right, so I hope you enjoyed this video, and we'll talk to you soon. Thanks a lot. Bye.